Welcome to educator.com. In this lesson we're going to be learning about the greatest common divisor. We're going to be learning about finding the greatest common divisor, and that means we're going to find the largest factor of two or more numbers. The greatest common divisor is also oftentimes called the greatest common factor, and for short sometimes it's called the GCD or the GCF. There are a lot of applications for this. You could use the greatest common divisor in order to figure out how to distribute cookies evenly to a group of students, or you're going to see it used a lot in order to simplify fractions. A factor is a whole number that divides a non-zero whole number evenly with no remainder. So for example, 1, 2, 3, and 6 down here, the 1, 2, 3, and 6 are all factors of 6 because all of these numbers could be divided into 6 evenly with no remainder. A common divisor is a factor or a divisor that two or more numbers share. So what they have in common. So here we have 1 in common, 2 in common, 3 in common, and 6 in common. So those are common divisors. The greatest common divisor, also known as the greatest common factor, is the largest one shared by both. So the largest one shared by both in this case would be 6. So the GCD of 6 and the GCD of 24, the GCD of the two numbers, is 6. Find the GCD by listing divisors. Now when you're listing divisors, remember to use the pairs because in creating lists it's very easy to drop a factor, especially when the numbers are large. So what I mean by creating pairs is 27. 1 times 27, that's a pair. 2 doesn't work. 3 times 9. 4 doesn't. 5 doesn't. 6 doesn't. 7 doesn't. And 8 doesn't, and then you're up to 9. So you know that you've caught all the factors. So the factors of 27 listed are 1, 3, 9, and 27. Now let's find the factors of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6, and it meets in the middle. So I know that I've gotten all the factors because I used pairs. Common ones are 1 and 3 and 9. 9 seems to be the largest. So the GCD of 27 and 36 is 9. And we've done it by listing divisors or listing factors. Let's look at 18 and 49. First we have 1 times 18, and then 2 times 9, and then 3 times 6. And the factors will meet in the middle. Now with 49, I have 1 times 49. 2 doesn't work, 3 doesn't work, nothing works all the way up until 7. So here we see that the only factor they have in common, or the only divisor they have in common, is 1. So sometimes your GCD is just going to be 1. Now let's try using prime factorization to find GCD. I think that this is the preferred method because this way you will ensure that you don't forget about any factors. 42 breaks into 6 times 7, 2 times 3, and 7. 72 breaks into 8 times 9, 2 times 4, 3 times 3, bring down the 2, 2 times 2, 3, and 3. Now we've created the factor trees or the prime factorization for each of these numbers. Now you're going to look at what they have in common. They both have a 2 and they both have a 3. This one has more 2's and more 3's, but there's no match for it over here, and there's no match for the 7 over here. So what they have in common is a 2 and a 3. So take one set, don't take from both numbers, just one set. 2 times 3 is 6. So their GCD is 6. So in this way, you ensure that you don't have to create long lists and you don't have to worry about forgetting any factors because you know that the prime factorization of each number multiplied up will give you 72. So you know you've caught all the numbers down here. Let's try 21 and 63. This is 3 times 7. This is 7 times 9. 3 times 3 times 7. So they both share a 7, and they both share a 3. So let's take one set. 3 times 7 is 21. So the GCD of 21 and 63 is 21. And you can think about what factors do they share. Here it shared a 2 and a 2 and shared a 3 and a 3. And when you multiplied them together, you created the largest factor. They both shared 6. They share a 3 and a 3, a 7 and a 7, and when you multiplied them together, you created their greatest factor, 21. The captain of a police department evenly distributes 27 reports, 45 forms, and 81 sets of fingerprints to his officers. What is the greatest possible number of officers in his department? So since he's been able to give all this work out evenly to all of his officers, we can figure out how many officers there are. So let's take 27, 45, and 81 and find their common factor. The common factor would be how many officers there were. So we have 3 times 9, which breaks into 3 times 3 times 3. We have 5 times 9, 3 times 3, and 5. And we have 9 times 9. This is a 3 here. So they all share a 3, and they all share another 3. These two numbers, 27 and 81, share another 3, but it's not shared by the 45. So we can't count that as one that they all have in common. So let's just take one set, which is 3 times 3, and that's 9. And we can go back and check. Can you divide 27 by 9 evenly? Yes, you get 3. 45 divided by 9 evenly? Yes, you get 5. And 81 divided by 9 evenly? You get 9. So if we were to think about it in the context of the problem, there were 9 officers. And each officer, oops, spelled this wrong, there were 9 officers. And each officer got 3 reports, 5 forms, and 9 sets of fingerprints. A plumber has 2 pipes measuring 14 inches and 35 inches. He wants to cut these pipes into equal lengths without wasting any of the material. How long should each pipe be? So he wants to cut the pipes at the same lengths, but he doesn't want to have any left over. So that means we should be able to find a factor that we can divide into both evenly. So let's find their common factor. Well, we've gotten to the prime factorization. We see that they both share 7. So each pipe should be 7 inches long. If he cuts the pipe 7 inches long, this one cut 7 inches long will give him 2 pieces, and this one cut 7 inches long will give him 5 pieces. And each piece is the equal length because each piece is 7 inches, and there will be nothing left over, no remainders. Let's find the GCD of 32, negative 24, and 40. In this case, notice we have a negative number, but that negative number is not going to affect us because you know that if I can divide the other two by a positive factor, I can call this also the positive factor and say that its pair would be the negative. For example, let's try it. Four times 8, 2 times 2, 2 times 4, 2, 2, 2, 2, and 2. 6 times 4, 2 times 3, 2, and 2. 4 times 10, 2 times 5, 2, and 2. So let's find all the common factors. They all have a 2, and another 2, and another 2. And nothing else is shared. So in this case, if you wanted to say that one of the factors was a negative, you could call this 3 the negative. So that way, these can all be positive factors that are all the same. So let's just take one set, and that equals 8. Let's go back and check our answer. 32 divided by 8, yes, that works. You get 4. Negative 24 divided by 8 works. You get negative 3. 40 divided by 8 works. You get 5. So the GCD, the number that can be factored into all of these numbers evenly, is 8, the largest one that can be factored in. Students from various schools have volunteered to help at animal shelters. The director wants to put the same number of girls and boys in each group of volunteers. There are 57 boys and 76 girls. How many groups will be formed? So let's take 57 and 76. Remember the divisibility rules that we learned in the prime factorization lesson. 57 appears to be a prime number. However, remember to always try the numbers 3 and 7. So if I try 57 divided by 3, notice it'll go in ones and it'll go in 9. So in fact, I can do 3 times 19. And here, 76. Let's try if 3 will be a factor. Remember the divisibility rule says that if we add the numbers, the digits, 7 plus 6, that's 13. Is 13 divisible by 3? No, it's not. However, we see that it is an even number, so I know that at the very least I can divide by 2. We'll go in 3 times, and we'll go in 8 times. Okay, so I can start with 2 times 38. And bring down the 2, and I know that it's an even number, so I could divide by 2 again. And that should be 19. And so the factors that are shared are 19. And that's the only factor that's shared. So the GCD is 19. So how many groups can be formed of even numbers? 19 groups. So let's divide by 19 and see if that works. 3 divided by 19 is 4. So that means each group is going to have 3 boys and 4 girls. Each of the 19 groups will have 3 boys and 4 girls. What is the GCD of any 2 prime numbers? Explain. Well, GCD means the common factors, and we know that prime numbers always have factors of 1 and itself. So, for example, 17. It's a prime number, its factors are 1 and itself. How about 2? That's a prime number, its factors are 1 and 2. Or 3, also prime number 1 and 3. So do you see a pattern occurring? The GCD of any 2 prime numbers, because prime numbers in their nature have no other factors, is always going to be 1. And an explanation could be because prime numbers have factors of 1 and itself. George's mom carefully counted out the number of party favors she had to buy so that each guest, including George, would get the same amount. She bought 12 sparklers, 36 noise poppers, and 48 water balloons. How many children are at that party? So how many children are at that party? So we're going to be including George. So let's figure out how many, if she gave out the 12 sparklers evenly to everyone, the 36 noise poppers evenly to everyone, and the 48 water balloons evenly to everyone. So we're going to find what number we can divide into all 3 of these numbers evenly with no remainder. 3 times 4, 2 times 2, 3. This is going to be 2 times 18, 2 times 9, 3 times 3. This could be 4 times 12, 2 times 2, 3 times 4, 2 times 2, 3, 2, and 2. Let's see what factors they share. A 2 in all of them, a 3 in all of them, and another 2 in all of them. So in fact, we've used all these factors, and we know the product of these factors are 12. So it's seeming that the GCD is 12, so that there are 12 children at the party, including George. Let's see if it divides evenly. 12 divided by 12 is 1. So each child at the party will get 1 sparkler. 36 divided by 12 is 3. Each kid at the party is going to get 3 noise poppers. And then lastly, 48 divided by 12 is 4. Each child at the party will get 4 water balloons. So she's divided all the party favors evenly between all 12 students, or all 12 children in this case. Thank you for watching educator.com.